Let's get right into it. Number 7. Infinite versions of you may exist. Right now, somewhere in the universe, there is a version of you who made a different choice this morning. A version who took a different job, lives in a different city, never listens to this. Not as a metaphor, not as philosophy, as a genuine, measurable consequence of how quantum mechanics appears to work at the most fundamental level of reality. In 1957, a Princeton physicist named Hugh Everett III published a paper that his advisor, the legendary John Wheeler, initially dismissed as too radical for mainstream consideration. Everett's many worlds interpretation of quantum mechanics proposed something almost incomprehensible: that every time a quantum event occurs, a particle going left or right, a photon passing through a slit, reality doesn't pick one outcome. It splits. Both outcomes happen, each in its own branching version of the universe. Every quantum measurement, billions of times per second in every atom of your body, generates a new branch of reality. The universe doesn't choose, it duplicates. This isn't a fringe idea anymore. A 2021 survey of physicists found that the many worlds interpretation is now among the most widely accepted frameworks for understanding quantum behavior. And if it's correct, the implications don't stay small. The number of branches isn't just large, it's functionally infinite. In some branches, you were never born. In others, you've already died. In a statistically enormous number of them, you are living a life almost identical to this one, but with microscopic differences. A sentence you said slightly differently, a coffee you didn't finish, a street you crossed a second earlier. Each of those branches is equally real, equally physical, equally you. What makes this genuinely hard to sit with isn't the scale. It's the identity problem. Which version of you is the real one? Physicists like Max Tegmark at MIT argue there is no real one. The you that is watching this right now is one thread in an infinite tapestry of identical but diverging versions. Every version believes, with complete justification, that they are the original. The next time you make a decision, any decision, understand that you are not choosing between paths. You are splitting into all of them simultaneously. You just don't get to watch. Number 6. Time may not really exist. Think about how completely your life is built around time. Deadlines, heartbeats, aging. The entire architecture of human experience depends on time moving forward, one moment giving way to the next in a relentless, irreversible sequence. Which is why it's so disturbing that some of the most serious physicists alive today believe time may not be a fundamental feature of reality at all. The problem started with Einstein. His equations of general relativity treat time not as a universal clock ticking in the background, but as a fourth dimension woven together with space, something that can bend, stretch, and slow down. GPS satellites have to correct for the fact that time runs faster at their orbital altitude than it does on the surface of the Earth. This isn't a quirk, it's a measurable, engineered reality. But the far stranger issue is what happens when you try to combine general relativity with quantum mechanics, the two most experimentally verified theories in the history of science. When physicist Bryce DeWitt merged their equations in 1967, he arrived at something called the Wheeler-DeWitt equation. The equation describes the universe, and in it, the variable for time has vanished. Completely. As if the deepest mathematical description of reality has no need for it. Physicist Carlo Rovelli, one of the founders of loop quantum gravity, has spent decades developing this idea in his work. His conclusion, laid out with uncomfortable clarity: time as we experience it, as a flow, as a present moment moving toward the future, is not what the universe is doing. It is what our brains are doing. We are biological systems that process information in one direction, and we experience that directionality as time. But the universe itself, at its most fundamental level, may simply be a static four-dimensional structure with no preferred direction, no now, no movement at all. Every moment that has ever happened, your childhood, this moment, your death, may all exist simultaneously in a four-dimensional block, like frames of a film sitting frozen on a table. You don't experience the past because it's gone. You don't experience the future because it hasn't happened. You experience the present because your consciousness is located at one point in that structure, just like you can only be in one place in space at a time. If that's true, then nothing is actually happening. Everything has already happened. And the sensation of moving through time, the most immediate, undeniable experience of being alive, may be the most elaborate illusion in the universe. Number 5. The universe could loop like a game map. In classic video games, when you walk off one edge of the map, you instantly appear on the other side. The world wraps. The space has no edges. It's finite, but it's also boundless. What physicists call a toroidal topology. In 2003, a team of cosmologists led by Jean-Pierre Luminet at the Paris Observatory published a paper in Nature proposing that our universe may work in exactly this way, not as a metaphor, as a geometric description of the actual shape of space. The evidence came from the cosmic microwave background, the faint afterglow of radiation left over from the first moments after the Big Bang. When NASA's WMAP satellite mapped this radiation across the entire sky in 2003, researchers noticed something unexpected. The temperature fluctuations at the largest scales were weaker than standard cosmological models predicted. One explanation: the universe isn't large enough to support those large-scale fluctuations because it wraps back on itself before they can fully form. If the universe is toroidal, then light traveling in any direction long enough would eventually return to its starting point. In principle, if you pointed a powerful enough telescope in any direction and waited long enough, you might see the Milky Way, not as it is now, but as it was billions of years ago, before our solar system formed. You would be looking at the back of your own head, across cosmic time. But the implications reach further than the geometry. A finite, looping universe has a hard boundary on the total amount of matter and energy that exists. That means there is a hard boundary on the total number of possible configurations of that matter and energy. And if the number of possible configurations is finite, and the universe is old enough, then every possible arrangement of particles must eventually repeat, including the arrangement that produced you. Including this exact moment, your exact thoughts, this exact sentence, recurring not once, but infinitely. The German philosopher Friedrich Nietzsche called this idea the eternal recurrence, and he considered it the most terrifying thought a human mind could confront. Physicists call it the Poincaré recurrence theorem, and in a finite looping universe, it isn't philosophy, it's mathematics. You have lived this moment before, you will live it again. Every version of your life, the best moments and the worst, is scheduled to repeat without end, across timescales that make the current age of the universe look like a rounding error. Number 4. Our universe might be inside a black hole. When a star massive enough collapses at the end of its life, gravity crushes its core to a single point of infinite density, a singularity. The laws of physics, as we currently understand them, break down completely at that point. Our equations produce nonsense. We genuinely do not know what happens there. In 2010, physicist Lee Smolin at the Perimeter Institute in Canada published work developing a theory called cosmological natural selection, building on earlier ideas from 1992. His proposal, the singularity at the center of a black hole, doesn't represent the end of something. It represents the beginning of something else. A new universe, born from the collapse, with its own space, its own time, its own physical laws, slightly mutated from the parent universe that spawned it. If Smolin is correct, black holes aren't cosmic drains. They are cosmic wombs. And the universe we live in isn't the original. It is the offspring of a black hole in some parent universe we will never observe. Our Big Bang, the origin point of everything we know. Every galaxy, every atom, every moment of history was triggered by a gravitational collapse in another reality. Here is where it stops being abstract. There are estimated to be around 40 quintillion black holes in the observable universe. 40 quintillion. Each one, according to this theory, potentially generating a new universe, which means universes are not rare accidents. They are the standard product of mature cosmologies. They breed, and the universes that produce the most black holes produce the most offspring universes, whose physical constants are tuned to produce even more black holes, a cosmic natural selection for fecundity. Which means our universe's physical constants, the ones that allow stars to form, that allow chemistry to exist, that allow you to be alive and watch this, may be precisely the constants that maximize black hole production. Not because a creator designed them for us, but because universes that generate us also generate the most offspring. We are a side effect of a physics optimized not for life, but for reproduction. And right now, Every black hole in our night sky may be seeding new universes, with new stars, new planets, new forms of matter we cannot conceive of. Entire cosmoses are being born in places we call dead. We are not the universe. We are one generation of it. Number 3, the Big Bang might not have been the beginning. We've been told the story since childhood. 13.8 billion years ago, everything that exists exploded out of a single point. Time began. Space began. The universe began. The Big Bang is the opening line of every textbook on cosmology, which is why it matters enormously that some of the most respected physicists in the world no longer believe it was actually the beginning. In 2010, mathematician and physicist Roger Penrose at Oxford University, who would go on to share the 2020 Nobel Prize in Physics, published a theory called conformal cyclic cosmology. His argument, the Big Bang was not a beginning. It was a transition. The universe before ours ended not in darkness, but in a state of maximum entropy, a cold, smooth, featureless void populated only by photons, with all matter having long since decayed. Penrose showed mathematically that this extreme endpoint of a dying universe and the extreme starting point of a new Big Bang are, in a precise mathematical sense, identical. One flows into the other without interruption. Our universe is one cycle in an endless chain stretching infinitely into the past and infinitely into the future. In 2023, Penrose and his colleagues published evidence they claimed supported this model. Faint circular patterns in the cosmic microwave background radiation. Rings left over, they argued, from the gravitational wave events of black hole mergers in the universe before ours. Signals from a universe that ended. Fossils of a cosmos that predated everything we know. If conformal cyclic cosmology is correct, the question, what came before the Big Bang, has a real answer. Another universe, which itself came from another, which came from another, without beginning and without end. There is no moment of creation. There is no original. There is only the cycle. And here is the part that truly strains comprehension. Each cycle may last trillions upon trillions of years. The current age of our universe, 13.8 billion years, may be a small fraction of a single iteration, which is itself one of an infinite series. The mathematics of infinity applied to cosmology produces a reality so vast and so old that the numbers lose all human meaning. Every star that has ever burned, every civilization that has ever risen and fallen, every human thought ever recorded, all of it a brief flicker in a structure that has no beginning and will have no end. The Big Bang was not the start of the story. We opened to a page somewhere in the middle. Number 2. Space could have hidden extra dimensions. You navigate 3 dimensions every day without thinking about it. Length, width, depth. Every object, every distance, every direction you have ever experienced exists within these 3 coordinates. It is so fundamental to human experience that it feels less like a fact about the universe and more like a logical necessity. There cannot be a 4th spatial dimension. What would it even mean? That reaction is exactly why what physicists discovered in the late 20th century is so disorienting. String theory, the leading candidate for a unified theory of everything, the framework that attempts to reconcile general relativity with quantum mechanics, requires not 3 spatial dimensions, but 10. Or 11 in its extended version, M-theory. The extra dimensions aren't optional flourishes added for elegance. They are mathematically required for the equations to remain consistent. Remove them, and the theory collapses into nonsense. In 1998, physicists Nima Arkani-Hamed, Savas Dimopoulos, and Gia Diwali published the ADD model, proposing that these extra dimensions are real but compactified, curled up at scales smaller than the nucleus of an atom, which is why we've never detected them directly. The Large Hadron Collider at CERN was designed in part to look for their signatures, microscopic black holes that would indicate gravitational energy leaking into these hidden dimensions. No microscopic black holes have been found yet, but the search continues. What stops the mind is the experiential gap. A drawing living on the surface of a sheet of paper has no way to perceive or access the 3rd dimension. The space above and below the paper exists. Objects can move through it, but the 2-dimensional being is structurally unable to detect it. We may be in an identical situation. There may be entire dimensions of space that objects move through freely, that forces propagate along, that influence our reality from just outside our ability to perceive, and we have no more way of detecting them directly than a drawing can reach off the page. Some physicists have proposed that the weakness of gravity, far weaker than any of the other fundamental forces, and by a factor that seems almost absurdly large, may be explained by gravity leaking across extra dimensions. The force that holds galaxies together, that shapes the large-scale structure of the universe, may be a diluted shadow of something far stronger operating in a space we cannot access. There may be an entire geometry of existence that you have never experienced and cannot experience, pressed up against your reality from directions your brain has no word for. Number 1. The universe might be a hologram. In 1993, Nobel Prize-winning physicist Gerard 't Hooft published a paper proposing one of the strangest ideas in the history of science. He suggested that everything in our three-dimensional universe, every galaxy, every atom, every thought, every experience, is mathematically equivalent to information encoded on a two-dimensional surface at the boundary of the universe. Like a hologram on a credit card generating the illusion of depth, our three-dimensional reality may be a projection from a flat, lower-dimensional structure we can never see or access directly. This is not metaphor. It is a precise mathematical statement called the holographic principle, later developed by Leonard Susskind at Stanford, and extended into what became the most important theoretical discovery in physics of the last 3 decades, the AD-S-CFT correspondence, published by Juan Maldacena in 1997. Maldacena demonstrated a rigorous mathematical equivalence between a 5-dimensional universe with gravity and a 4-dimensional universe without gravity on its boundary. The two descriptions are different. The physics they predict is identical. Neither is more real than the other. The implications have been developing for nearly 30 years, and they are not getting easier to accept. In a holographic universe, 3-dimensional space, the thing you move through, the thing separating you from everything else, may not be fundamental. It may be an emergent property, something that appears as a consequence of how information is organized on a surface that exists in fewer dimensions. Space itself might be made of something else entirely. Entangled quantum information. Physicist Mark van Ramsdonk at the University of British Columbia published work in 2010 demonstrating that quantum entanglement between particles on the boundary surface is what stitches together the geometry of the interior space. When entanglement is removed from the equations, space tears apart. This is not a poetic analogy. It is a mathematical result. Space, the fabric of reality we navigate every moment, is built from the correlations between quantum information states on a surface we cannot observe. What this means for your experience of the world is this: the sensation of being here, in this body, in this room, surrounded by objects at measurable distances. All of it may be the output of a calculation happening on a structure that exists at the edge of reality in fewer dimensions than you have ever experienced. You are not in the universe. You are a pattern in the universe's code, and the code runs somewhere else. The physicist John Wheeler, one of the architects of modern cosmology, spent the final decades of his life pursuing one central question. He wanted to know if the universe was, at its core, made of information. Not matter, not energy, information. He called the idea it from bit. Every particle, every field, every law of physics derived from answers to yes or no questions, bits, the most fundamental substrate of reality. If he was right, if the universe is a hologram and matter is made of information, then the question of what is real no longer has an obvious answer. Everything you have ever touched, everyone you have ever loved, the entire history of the cosmos, may be data in a computation whose origin, purpose, and hardware lie forever beyond the edge of what we can observe or understand. And perhaps the most unsettling part of all, the math works. We have no evidence that it's wrong. That's it for today. Subscribe for more.